This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. It's episode 762. This week we welcome back Dr. Joe Spurgeon and introduce Danny Gough. Get it right. Gough. I'll get it right, Danny, to discuss issues with moisture and mold in wall cavities. This appears to be a growing problem. What are the reasons? How do you inspect for it? Show clients there's mold. Does it always have to be removed? How much is too much? We'll talk about all those things when we get back with our guests. Before we get started, let's thank our sponsors. They're the reason we can continue doing the show. IAQ Radio's marquee sponsor is the Institute for Inspection, Cleaning, and Restoration Certification, IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry at iicrc.org. IAQ Radio Association sponsors are the Restoration Industry Association, RIA, at restorationindustry.org. The Environmental Information Association, EIA, at eia-usa.org. IAQ Radio industry sponsors are Particles Plus at particlesplus.com. Tramex Meters at tramexmeters.com. EMSL Analytical Inc. at emsl.com.
And now you can win a cool prize. It's time for the IAQ Radio Trivia question. Be the first to correctly answer. Simply email your answer to czlotnick at cs.com. Or if listening live, just text your answer from your computer. And now, here's the Z-Man.
Hello, everyone. I'm happy to report that Paula Shank with the University of Connecticut Division of Occupational Environmental Medicine was first to correctly differentiate between endotoxin and mycotoxin. Real competitive on the trivia last week. Here's today's IEQ Radio Trivia question. On September 12th, 1958, this day in history, Jack Kilby presented his findings to Texas Instruments Management for a discovery for which he was later awarded a Nobel Prize. What did Jack Kilby invent?
All right. Dr. Joe Spurgeon has a multidisciplinary doctorate degree in analytical chemistry and environmental health from the University of Pittsburgh, and he was a certified industrial hygienist from 1993 to 2013. He's performed numerous residential and commercial investigations involving water and microbial contaminants. He's taught courses on mold, sampling, and data interpretation methods, and has served as an expert witness in numerous mold cases. His books are available at expertonmold.com. Danny Gough calls himself a slow learner trying to retire. He works out of Yadkinville, North Carolina, and his specialties include building performance consulting, psychometric analysis, and advanced humidity control. He designs HVAC systems for low-energy buildings. He does geothermal, solar, radiant, and he services hot water. He is an approved instructor for the National Association of Home Builders and the Air Conditioning Contractors of America. And he also provides continuing ed for the American Institute of Architects and Builders with the North Carolina Licensing Board for General Contractors. Gentlemen, welcome back. Welcome back, Joe, and welcome for the first time, Danny.
Thank you, Joe.
Great to have you guys. Hey, before we get into Joe's presentation, Danny, let me introduce you a little bit to our audience. We gave you a little background there. Can you tell our audience a little bit more about what got you interested in this particular topic? Mold in wall cavities, a growing issue.
Well, I've been seeing a pattern of folks that are insisting that they run their houses in the summer really, really frigidly cold, seeing anywhere from 65 to 68 degrees and sometimes colder. And so it caught my eye, this really super cold house, whenever there's water starts running out of the plates, the receptacle plates and the wall switches. And then I began to wonder about the psychometrics. I did a simple model. The University of Vermont has a wall modeling tool, and it showed on the conventionally framed houses that we do routinely here in the Southeast with stick frame and R15 fiberglass some type of cladding and drywall, that the condensation line actually occurs about an inch before it sees the back of the drywall. So that told me that it was a foregone conclusion that we should expect condensation on the backside of the drywall when you turn the house down to meat locker temperatures almost. And I've seen more and more of this as for the last couple of years. I also have interest as to why this is happening in terms of the physiology. And there's some different theories. I'm not sure they're theories yet. They're just ideas. They haven't been massaged yet to become theories. But I'm concerned about the moisture and the consequential expected consequence of the amplified mold. And I presented that to Dr. Joe, and I said, hey, I think we got a problem here. I think people run their houses this low, they're going to have some mold exposure. And as Dr. Joe does, you know, he has to straighten me out. I've told him he has a spiritual gift of making me humble, because I come to him thinking I know stuff, and about a minute later, I realize I don't really know much at all. And so he said, just because we have high mold spore counts in the wall doesn't necessarily mean there's occupant exposure. And so that's what he's here to straighten that topic out about. And we still, at the end of the day, will probably still have questions about which houses will show occupant exposure and which will not. But that's essentially why I'm here. Well, I'm here today is what got the ball rolling, is Dr. Joe trying to straighten out something that I had wrong in my head.
Now, Joe, you came at this from a little different perspective. Maybe if you would fill our audience in on how you became much more involved with this issue, and then we can go into your presentation.
Well, I got really deeply involved. I've been doing wall cavity sampling for years. Matter of fact, I've been using it quite frequently as a sampling method. But I got involved because in a hot, humid, subtropical climate like Houston, Texas, there's a lot of wall cavity sampling being used inappropriately. And I was asked to look into that situation down there. So I've got a lot of data on that. And there's a lot of background information I think that we need to discuss, because in general, I believe wall cavity sampling is a very good technique, but the way it's being used inappropriately, and we need to talk about it as an industry.
Do you feel like there's more of an issue today than there was in the past with wall cavity concerns? And especially, I'm not talking about liquid water either, you know, where you've got a leak. Like I just did a job yesterday with my son, and the siding's put on wrong. There is no house wrap, believe it or not. There's no flashing at the bottom of the siding where it meets the brick. It's just a nightmare. I don't think you're necessarily talking about just those types of situations.
No, I don't know. You can either believe or not believe in climate change. But if the temperatures are increasing, you're going to have more moisture in the air. You're going to have higher relative humidities. You're going to have higher water activities on the surfaces of drywall. And you're going to have more mold spores in wall cavities. And those are going to become background conditions. And unless we talk about them and understand those conditions as they evolve, I think we're going to start making inappropriate decisions. So I think we need to start talking about it.
Hey,
Well,
Joe,
go ahead, Danny.
let me infuse another factor. If you're not on the climate change bandwagon, is fundamentally when we started our myopic focus on energy efficient homes, and that would be both new homes and existing homes, because every good American during the Jimmy Carter days, you know, was sealing our homes and putting more insulation in. And as Dr. Joe Stubrick has taught us, is that's great that it saves energy, but that energy is no longer available to dry our homes. And so since we've cut the energy consumption That's a secondary consequence that I don't think many people actually plan for. So our homes are staying wetter longer. There is no such thing as incidental leakage anymore because we just simply do not have the energy exchange necessary to dry these assemblies now. So if you are not a climate change fan, there's this huge issue with the product that we're building today. Is it doesn't resemble what we built 30 to 40 years ago.
So rather than talking about equilibrium, surface relative humidity, and topics like that, which I think Danny's probably good on, I'm just going to be talking about the wall cavity sampling rationale. And I think that's going to form a basis for the following discussions. So why was the wall cavity sample collected? Why in that location with that sampler? Why was it analyzed using those methods and interpreted using those criteria?
And Joe, let me ask real quick. Those are the kind of things you, as an expert looking at reports, are looking for in that report.
Well, as an inspector, those are the questions I ask myself before I actually start collecting my samples. That's what I rarely see when I review a report. But every inspection I do, I'm asking myself these questions. Every sample I collect, I ask myself these questions. Okay.
All right.
I think it's very important.
Agreed.
So
if you're going to sample, you better know why, huh?
yeah, really. So why was the wall cavity sample collected? And to identify locations for possible remediation, that is to assess building-related contamination, not to assess occupant exposure. So if you look at AIHA Recognition, Evaluation, and Control of Indoor Molds, section 10.2.3, it states the use of wall cavity air samples should never be used in an attempt to determine exposure to occupants. So why we're collecting wall cavity samples is to assess building-related contamination. And if we look at this is airborne ASPEN in 117 rooms versus the average result for ASPEN and wall cavities in the same room. And what we have is room ASPEN versus the ASPEN in the wall cavities. And the correlation coefficient is 0.07. A coefficient of 0 is no correlation. A coefficient of 1 is perfect correlation. And what we have is just a flat line. There's no correlation between the ASPEN in the room and the ASPEN in the wall cavity, up to over 1 million ASPEN in the wall cavity. So whatever's in the wall cavity is staying in the wall cavity. AIHA says don't do it. My data says don't use what's in the wall cavity to assess occupant exposure. It just doesn't work. Okay. Methods for identifying locations to assess possible remediation. What's a wall cavity sample? It's just one of 5 methods you could use to assess the condition of wall cavities. Wall cavity sampling, moisture meter, thermal imaging, borescope imaging, destructive testing. However, wall cavity sampling and borescope imaging allows you to look at current and past water intrusions. Okay. And what I'm going to be discussing is wall cavity sampling, but there's other methods that you could be using. Okay. Some better, some worse. All have pros and cons. Very important question. Why was the sample collected in that location? Why don't you just take a sample from the nearest electrical outlet or light switch? The question is, what's the question the sample is intended to answer? And I'm going to give you 3 examples. I had a project, a residential house where there was 118 windows. My task was to identify 5 windows to test using the ASTM water penetration test to look for leaks. I took wall cavity samples from 20 windows, and from those 20 windows, I selected 5 I thought were leaking based on the wall cavity samples. And when we used the ASTM water penetration test, all 5 windows leaked. So the wall cavity samples were 100% accurate in identifying leaking windows.
Hey, Joe, I got to ask, who has 118 windows in their home?
Well, this is Southern California. It's Hollywood, baby. It's Hollywood.
Okay.
You have a homeowner telling you the last time it rained, the living room window leaked, but it hasn't rained in 2 months. So what methods are you going to use to determine whether or not you think that window actually did leak? I use a wall cavity sample. I'm going to take half the sample from underneath the left side of the window, half the sample underneath the right side of the window. And I'm going to see if that wall cavity is contaminated. Okay. You can't use moisture meter. You can't use thermal imaging. Wall cavity works pretty good. Let's say you have surface mold on the wall next to a bathtub. The tenant tells you that they haven't used the shower in the last 2 weeks because it leaks and the wall gets wet every time they use the shower. The landlord tells you, no, it's not the shower leaking. It's just a kid splashing water onto the wall next to the bathtub. Wall cavity sample is going to tell you some information. You test the wall cavity. If you get Stachybotrys and atomium, you know probably the shower was leaking. If not, it's probably just surface mold from splashing water. So why are you sampling that location? You have an intended purpose. You have a question to answer when you sample that location. Why did you use a particular sampler? You can use an aerosol or Allergenco D with a wall check probe or an inner wall probe, or I use a PCM filter cassette. But I have a reason, and you should have a reason for using a particular sampler when you sample a wall cavity. Okay. This is, for example, a perimeter wall cavity, full height with insulation batt. The void space is about 79 liters. If you take a 2-minute aerosol, and most of the samples I see are 5-minute aerosol samples, but a 2-minute aerosol takes out 30 liters from a 79-liter volume. So you're taking out 30% of the volume. Let's just assume you start with 1,000 spores per cubic meter. By the time you end up taking that 30-liter sample, you have an average concentration of 620 spores per cubic meter. That means the sample average concentration was 800. So the laboratory is going to come back with a concentration of 800 spores per cubic meter when you started out with 1,000 spores per cubic meter. If you use a filter cassette, you're going to get a reported average of 900 spores per cubic meter, for example. So people don't consider a 20% error to begin with just on sample volume by using an aerosol type cassette. If you're under a 3.0 window, a filter cassette gives you a 23% volume removed. An aerosol cassette, 230% of the volume is removed. Just consider that.
Joe, is there any variable there with respect to insulated versus non-insulated walls?
Yeah, the void space of insulation I take is 85%. So there's a minor variation, maybe 75 liters versus 79 liters for an interior wall versus, something like that.
And that's with fiberglass batt insulation. Is there any other kind of insulation that maybe makes it more difficult or almost impossible to take a sample?
I haven't tried with other types.
Okay.
I have tried sampling with perimeter and interior walls. There's no difference in airflow and concentrations between the two, interior and exterior. But I have not tried any other type.
If it was, spray foam or something, you just couldn't do it.
No, well, not spray foam, no, but wool or something like that, I haven't tried.
Okay. All right.
All right, so if you're using an air cell, you're going to get spore counts. That's it. If you're using a filter set, you can get spore counts. You can use qPCR to get species. Why would you want that? Because you can track sources. qPCR, you can take airborne, you can take air supply grills, you can take hard surfaces, you can take carpet dust, you can take air return filters, and you can track sources. You can also do cultures and get species and viabilities. Why might you want viabilities? Some insurance companies, for example, are interested in age. And here's Aspen by culture and microscopy. And you can get some idea of the age of the incident by just taking the ratio of cultures to total spores. So again, depending on what kind of sampler you're using, you can get a lot more information or a lot less information. Okay. What about quiescent or aggressive sampling? If you look at the ratio of aggressive to quiescent sampling, you get a lot more spores detected using aggressive sampling. If the objective is to detect mold, then you want to use the most sensitive methodology, which is aggressive sampling. And if you have a moist, damp, or wet wall cavity, it's going to be very hard to get the spores airborne. So again, you would want to use aggressive sampling to get the airborne spores so that you can detect them.
Joe, how would you do aggressive sampling?
Well, if you want to either use the palm of your hand, or I use a rubber mallet
Okay.
around the circumference of the sample area.
Okay.
You just don't want to use a black mallet on a white wall.
Right. Okay. What about blowing air in, like a little, leaf
No,
blower? No.
no. I mean, not unless you want just so much dust that obscures the sample.
Okay. Thank you.
Okay, I would not do that.
Okay.
Okay. Okay, so why was the sample interpreted using that method? So we have three basic methods. The reference method, indoor versus outdoor. I see a lot of people comparing the wall cavity sample to the outdoor air. I mean, why not? They were both collected using an air cell sample. I don't recommend doing that. A control method, you could possibly compare the result from a potentially contaminated wall cavity to what you think is an uncontaminated wall cavity or window. We have what I would call a database method, that is, compare your current sample to previously collected wall cavity samples. That's essentially an extension of the control method. So you have various methods. The least preferable method, I would think, is comparing a wall cavity sample to the outdoor air. I see that done routinely. I think that's a very poor method. This is a table from a report that I reviewed, reporting airborne samples and wall cavity samples in the same table, treating them identical, interpreting them in the same way. So again, I don't prefer that method. This is very common to what I see. This is an example. This is background mold in wall cavities from a moderate climate. This is coastal California, which is an irrigated desert. And background concentrations, this is the background concentration that I'm talking about, up to about 25,000 spores per cubic meter of Aspen. And what I see commonly is somebody sees 10,000 spores per cubic meter of Aspen in a wall cavity, compares it to 300 spores per cubic meter outdoors, and recommends a $10,000 remediation. And it's just background Aspen.
And Joe, this is with spore traps?
Yes, this is with
Aerosol?
aerosols with a wall check sample probe. Now the sample probe there's a different curve for the inner wall and the wall check, but this is with the wall check.
Okay.
Okay. This is a background wall cavity in a hot, humid subtropical climate. This is Houston, Texas. All right. And here we have background aspen up to 75,000 spores per cubic meter. This is the background profile here. Okay, so it's even worse. But as you move from an arid concentrations like Southern California to Houston, Texas, we have 3 times the background concentration. But at 75,000 spores per cubic meter or less, you're still in the range of background aspen. Okay. So if we look at wall cavities just subject to infiltration of humid air, and this is in the Houston, Texas area, I looked at 392 wall cavity samples collected in houses not subject to water intrusion. 92% of the spores detected were aspen spores. They were xerophilic, low water activity species. 6% were cladosporium, 2% were other. So the characteristic is a lack of fungal diversity, essentially a monoculture of primarily xerophilic aspergillus with some penicillium. And that's basically all you detect. It's just aspergillus and some penicillium. Here we have detection of mold spores in water-damaged wall cavities, where there's an incident history of water intrusion and there is water damage. 113 wall cavity samples. Now we're getting, yes, aspen and a lot of it, but also Stachybotrys cattomium euocladium. So now the characteristic is a variety of hydrophilic indicator mold spores being detected. So we have a different characteristic. Okay.
So, and that's difference between humidity related issue and a water leak.
Just infiltration of humid air versus an incident history of water damage, and then infiltration of humid air and going to the nearest electrical outlet or light switch and sampling a wall cavity versus an incident history of water damage and going to the area of water damage and sampling a damaged wall cavity.
Gotcha.
Okay.
Thank you.
So let's talk about hidden mold that's subject to remediation and hidden mold that's not subject to remediation. In AIHA section 17.5.1, they define hidden mold as concealed, visible, colonizing growth of filamentous fungi on building materials or contents that is within the building enclosure. So hidden mold subject to remediation is concealed, okay, in wall cavity or interstitial spaces, growing, not just germinated, visible, confirmed by inspection. So here we have the variation of aspen concentrations with time of growth in 3 houses. So I was able to take the data in 3 different houses over a period of almost 6 years. So here we have the concentration of aspen in wall cavities over a 68-month period, 5.7 years. And what we have is the median concentration in the wall cavities for those houses. And it's constant. There is no growth. It remains constant. And here we have a photo from a borescopic photograph of just one of the wall cavities. I have a number of photographs. They all look the same. They're clean. There's no visible mold. So we have detectable spores in the wall cavity that's not growing, that's not increasing, that's not visible mold growth. And this is the general situation.
Joe, so with that slide, that's not the sill plate. That's a vertical stud, but we're looking at it sideways or what?
No, that is the sill plate.
Okay, that's a sill. It looks like there's some discoloration above that, at least in the photograph.
Like what, right here?
No, above.
Above?
Yeah, like right there. Yeah.
That's just spray. I mean, it's not mold.
Okay, no problem.
I mean,
That's
yeah,
fine.
we've opened the wall. There's nothing there.
Okay, I believe you. I believe
Yeah,
you.
and this is why I don't trust borescopes.
Okay, all right.
I've been in a project with 3 CIHs. We had nothing but false positives from borescope. I don't trust borescope.
Okay.
Joe, we got a text question. If there is no mold growth, does that mean the mold colony is dead or is still viable and alive?
No, this is the difference between you can detect mold with a microscope. So this is the difference between microscopic. There's a difference between mold that is not visible and mold that is visible. You need a relative humidity of about 80% to get non-visible mold growth. And you need a relative humidity of about 88% or more to get visible mold growth. So
Okay.
you have what they call aerial hyphae, and it's almost like a vine-like growth over the surface of the drywall, but it's not visible. And the spores are real. These are real spores, but it's not visible mold growth. And the thing of it is, if you remediate this drywall, you're going to have the same condition within 100 days, within 3 months.
Gotcha.
Okay, so it's a
Gotcha.
never-ending cycle if you recommend remediation.
Joe,
That's
would
the
this
issue.
would this be a good time to break and thank our sponsors, or do you want to finish up?
This is the last slide, really.
Okay.
All right. So if you have air infiltration and you're running around sampling electrical outlets and light switches just randomly, and you're detecting germinated mold in xerophilic gas pen, what you are going to have to do is at least do borescopic imaging to determine that you have visible mold before you have a basis for remediation. If you have an incident history of water intrusion and you're using directed sampling and you have mold growth of indicator molds, that's sufficient to recommend remediation, in my opinion. You can do borescopic imaging or destructive testing to confirm visible mold, but you don't even need to do that. Then you can remediate. And I'm just real quick, this is not appropriate. Going to the nearest electrical outlet, light switch, sampling. What's the question you're trying to answer? There is no question. To me, it's worthless sampling.
Joe, go back.
We're done.
Okay, if you go back to the slide where the outlet is, okay, let me ask you a question. Is it worthless sampling? No, the one with that shows the no, keep
the outlet.
The outlet.
There you go.
Okay, stop. Yeah. Okay. Is it worthless sampling because the cassette is going to collect, 360, so you're going to be pulling stuff in from the room as well as probably more from inside the room than from inside that cavity? Is that why it's useless, or is there another reason for that?
Well, this particular isn't even a wall cavity sampling.
Yeah,
I don't even know how you interpret the result.
Right. Okay. Yeah, understood.
But what I'm saying is I'm being told a lot of the initial courses are teaching people to
do that,
to take a wall cavity sample from the nearest electrical outlet or light switch.
I see.
And what I'm saying is all you're detecting is background mold.
Oh, okay.
And you're recommending $10,000 remediations for no reason.
Okay. Good.
That's my problem.
Okay.
Start teaching the method correctly in the initial courses.
All right. Let's go to halftime, Grayson. Thank our sponsors. We're a little behind, but we'll catch up. IAQ Radio's marquee sponsor is the Institute for Inspection, Cleaning, and Restoration Certification, IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry at iicrc.org. Our association sponsors are The Environmental Information Association, EIA's multidisciplinary membership, collects, generates, and disseminates information concerning environmental and occupational health hazards in the built environment at eia-usa.org. The IICRC, a nonprofit standards development and certifying body for the cleaning and restoration industry, iicrc.org. The Restoration Industry Association, the oldest and largest nonprofit professional trade association dedicated to providing leadership and promoting best practices through advocacy, standards, and professional qualifications for the restoration industry at restorationindustry.org. Industry sponsors are Particles Plus, feature-rich particle counters and air quality instrumentation. Count on us, particlesplus.com. Tramex Meters, innovation in moisture detection and humidity monitoring systems since 1974 at tramexmeters.com. EMSL Analytical Inc., providing high-quality, full-service laboratory services since 1981. EMSL.com. All right, we're back with Dr. Joe and Danny Gough. Joe, I missed one of these text questions, and for those of you texting, I don't have, for some reason, I can't type into the text today, but would you expect a more air leaky house to have a greater correlation between poor quality inside the walls and poor air quality inside the house? So I think he's kind of saying, there's more of a potential for air to come through that wall cavity and end up in the house.
Well, from what I'm finding, I'm working with newer homes. The primary source that I'm working for is basically infiltration from attics rather than infiltration through the exterior walls. So if you have leaky walls, you're talking about perimeter walls only. The homes that I'm working with are newer homes, and there's no difference between perimeter walls and interior walls. So maybe Danny's better to talk about, the older homes, leakier homes.
Gotcha. Danny, I want to bring you back on here. Comments or questions?
Well, we're talking about probably a little bit different scenario here and where I started, in that the older homes, my experience has been they use a lot of energy, of course, but that energy that's being exchanged, I don't see the issues in the older homes in terms of the mold risk. But I do see the newer homes, like Joe was saying, I do see the newer homes as presenting a higher risk. And so, again, because of our singular focus on airtightness and better insulation initiatives, and I'm not saying I'm not a fan of that. I'm just saying that we need to learn to do it properly, because there's just a lot of folks that are being put at risk for various adverse health symptoms. So did that answer your question, Joe?
Yeah, I think so. I got another question, Joe. You mentioned that you're seeing more air infiltration from attics. Okay, and
Yeah.
correct me if I'm wrong. And this is because the newer homes are better air sealed in the perimeter walls?
Well, I'm assuming that. For example, when I do an analysis by floor, the average aspen concentration on the second floor is about 300,000 spores per cubic meter. the average concentration in the wall cavities on the first floor is about 22,000 spores per cubic meter. So you can imagine this hot, humid air infiltrating from the attic through the wall cavity spaces, encountering the cooled surfaces on the second floor. The moisture condensing out, becoming drier and cooler. By the time it reaches the first floor, you have much less mold growth occurring by a factor of 13 or so.
I think the phenomenon there, Joe's, is the upper floor interior wall partitions are connected to the attic, as Dr. Joe said. And what you've got is, in most cases, the rim band area between floors are going to be, it's going to be a little more airtight than, but you put up interior walls, you've got railroad tracks of top plate and drywall junctions and everywhere you look. And if you want to see an example, just go into your attic and pull back the insulation. You'll see the two telltale signs of the stain in the fiberglass. I did have a case some time ago where we had an interior walk-in closet that manifested probably similar numbers to what you're getting, Dr. Joe, on the second floor. We had an interior walk-in closet that the entire drywall just fell off the wall, including the hangers and everything. And what was happening is that the cavity between the ceiling of the main floor and the floor of the second floor had a cantilever on the back. In other words, the floor system hung off of the first floor about 14 inches, and they had not sealed that from the exterior. And they placed a perforated vinyl soffit material. And of course, the air with the high dew point was totally unabated to go into that space, and it migrated into that interior wall cavity where this walk-in closet was, and condensed on the back of the drywall, and it just turned it into mush. And so, and the other factor, which Dr. Joe mentioned in our earlier Zoom meeting that our group had, is pressure differentials. And this is one of the things I think is the factor, at least in the way I'm thinking, is that as we made our houses more and more airtight, new homes, it doesn't take a lot of removal of air now to create pretty substantial pressure differentials and negative pressures in the house. I've had complaints from homeowners in new homes where the dryer has to run through 2 cycles to actually dry the towels. And that's because there's just not enough air holes in the house to provide sufficient makeup. And so now a small amount of pressure, and then we have, in addition to having folks that want it 65 in the house, we also have homeowners that think they need a jet engine range hood above the cooktop. And of course, Pete would probably want that, but the average homeowner doesn't need 1,400 cubic feet a minute being sucked out of their house. And so the physics is, if you have the hole, you got the air, and you got a driving force that's on steroids now. And I think all these factors are stacking up, and the stars are aligning to where we're seeing bigger and bigger problems, compounded by, it's basically folks, I guess, that no longer understand how to drive the house is a big factor. So,
Danny, you get out in the field a lot. You see a lot of new construction. I'm curious, are you seeing changes in the way we insulate, or are you still seeing basically our 13 fiberglass bat, or are you seeing more spray foam in wall cavities, or rock wool, etc.?
mostly the lion's share is still the fiberglass in our state. We do a 2x4 wall, 16 on center, typically with R15 bat. You'll see a commodity-based, sometimes you'll see a zip system, which is a more robust form of OSB sheeting. And you'll see some weather-resistant barrier attempts and some drywall on the inside, hopefully some vapor permeable latex. We don't see any of the vapor diffusion retarders in my state anymore, except for the higher elevations where we have climate zone 5. So there is drying potential some to the inside. But no, the spray foam is made a pretty decent dent in the market, but it's not by any means overtaken, the fiberglass. And then rock wool, not as much rock wool. And then, of course, we have alternative materials that I see from time to time, like the SIPS panels that are a really good way to build, and insulated concrete forms of various varieties as well. But most of what I see is stick and bricks and fiberglass typically.
And because of your climate zone, I guess you're still allowed to do R15 in walls.
Yeah, right now we are.
Two by fours R15. They haven't
Yeah.
adopted any of the newer codes.
No, our politicians are still arguing about that. So, but no, we're still on the R15 on the walls, R38 overhead, double pane windows, 0.3 U values.
And
So,
two by fours.
yeah, and anything above that you can do as it voluntarily, but it's minimum code is the bulk of what the public seems to think that it's good enough, I guess.
Now, in those projects that you sent us some photos, and I don't know, maybe Grayson, you could put up one or two of Danny's photos. I'm just curious, are these homes that have that two by four stick built fiberglass bat insulation in them that are being kept very, very cold that you're having problems with?
That, Joe, that's the common denominator of those photos I sent you, is the homeowners running their thermostats about 65 degrees. And this is a cathedralized ceiling, which I'm assuming that that's exterior air that's seeing the condensing surface, the backside of the drywall, and then eventually through capillarity, just sucking right through there. But yeah, this is just conventional framing. Nothing special about this house. Is probably 10 years old. No ductwork in this attic, and just we see these on every street corner. And
And what
that's
kind of insulation is in that wall?
just fiberglass.
And
And R30, I would bet.
30?
R30, yeah.
Okay.
And typically not installed, the very best, not installed without any gaps or voids. So, but we're seeing, this is what we normally see, is there's a difference in my mind between meeting the code intent and passing an inspection in my state. So whatever you got to do to get to pass is about all we see.
Interesting.
But the other photos I sent was actually a modular home, and the damage from that, a lot of that was on what we call the marriage wall, where the two modules hook together. And if you don't seal it from the wet crawl space and the humid hot attic, there's a lot of potential of air transported moisture there. Back to the R15 assembly, I went to the building science advisor and just punched in our code wall, and they have a mold index. Anything over 3 is you're getting into a little bit of the yellow area there for mold potential. And that wall actually scored with fiber cement siding, it scored about a 5, which is beyond what would be considered safe. And I'm not at all saying that Dr. Joe's the occupant exposure is being implicated by any of this. We got to sort all that out. And I noticed Dr. Grant was in our group today. I would love to hear her theory on why these folks think they need it this cold, for one thing. But this is beginning to be a bigger and bigger problem. And again, I think it's actually compounded by the air tightness efforts and also the mechanical exhaust fans. If in fact my proviso or my disclosure would be, if you have a homeowner that for whatever reason just insists on 65 degrees in my mixed humid climate, or our mixed humid climate here, that's a different house that needs to be built. Or build stick built and use something like aero barrier, which Jeff May mentioned the other day. It's actually, I look at it as a fix-a-flat system, for house leakage. That way, because I think most of the concerns that I'm seeing is driven by air transported moisture. And the other thing to remember is the building science advisor and all those thermal the models, the moisture models are for perfectly constructed walls. And I don't know about y'all states, but that won't happen in my state. And so they're not able to give a good handle on what that looks like in the models. So I just have to use common sense.
Hey,
So
Grayson, let's go to the roundup here. And if you have any of those photos that show a wall, Grayson, I'd like to see that. All right, before we wrap this up, I want to first give Joe any follow-up comments, etc. Then I want to give Cliff a chance to ask any questions he may have. Joe?
Yeah, well, again, what we were looking at there has really nothing to do with wall cavity sampling. That's obvious mold. But again, wall cavity sampling is one of the best techniques I've ever used if it's used appropriately. But again, what I see as an expert witness reviewing the reports that come across my desk is just the inappropriate use. It's not applied in directed sampling based on incident history. It's basically used as the end result itself. It's not used to identify locations for destructive testing, and it's not interpreted outside of an airborne sample. It's not interpreted as a wall cavity sample. So basically 3 issues that I have as it's normally being applied within the industry today, and it's not being taught correctly.
Interesting. And I think, we've got some comments on wall cavity check in general, and I think part of the problem is it has not been used properly for many, many years now. Cliff, let me see if you have any final thoughts or questions.
Probably not, not so much. I think, when we approach this from disaster restoration perspective, I mean, I could see issues following hurricanes and, so on and so forth, where you had a lot of moisture intrusion and you have high humidity and so on and so forth. But it would seem in a lot of the restoration situations, the more common ones, end up being, water leaks, pipe breaks, things like that, which I think would be most likely isolated. Very rarely are you going to have, the whole floor affected, or, unless it's a basement and there was, flooding or something like that. But, I think it's just real good general information. And, I never really thought about these background levels being anywhere near that high, inside of wall cavities is, particularly in hot, humid climates. I think really good information all around.
You guys did a little session with a chat group that we're on, and I noticed I didn't get to see the session, but I saw Danny or somebody posted something saying that Martine, who does a lot of work with sensitized people, they would actually, in some cases, be almost like a mold dog. They would tell you, okay, this wall, when I get close to this wall is when I have a problem. And I'm wondering, what are your thoughts there, Joe and Danny, as far as isn't part of the decision here up to the building owner? I mean, if someone says, hey, that wall's got to go, it's got to go. And where does occupant feedback come into all this, Joe?
Well, I think we're outside of wall cavity sampling. We're into occupant response. I don't think I can comment on that. That's anecdotal evidence, and if you want to go with anecdotal evidence, then I think we just have to go with it.
And it's kind of the homeowner's choice at that point. I mean,
Sure.
if they're telling you, hey, I got to get rid of this wall, I mean, you're telling them, hey, my sampling doesn't indicate there's a problem, but hey, no problem.
That's it.
All right. Before we go, Danny, any final thoughts?
no, I was just thinking that the buck stops with who writes the check. That was a saying I've heard once before. No, and I also wanted to mention I'm concerned about these folks that, there seems to be more and more of these folks that are hot natured. is the aero barrier might be a good solution for them if they're building, and also the SIPS product. And I notice one of the participants is Charles Leahy. He builds a great product here, not far from me, actually. And these are walls that will not present, well, the aero barrier. I don't think you're going to see the air transported moisture in those assemblies. So if we're going to continue this trend, then I think we're going to have to seriously begin to look at a different way to build our houses. Either that, or the mortgage companies are going to be foreclosing on piles of composted house stock. And of course, that goes into some of Steve Rick's perfect wall discussions and all that. But it's really becoming quite serious. I'm seeing more and more of these situations. Again, not waving the alarm flag that it presents any type of occupant exposure, but there certainly is some durability issues that I think we could agree on at the very least.
I'd also like to mention there's been some good discussion in the text, in the chat. I can't text for some reason, but we will include that in our afterthoughts, on afterthoughts after the show. We'll make sure that people can get hold of that discussion later on. Joe, before we go, any final thoughts or questions, or any final thoughts?
No, that's fine. I think we covered it.
Very good. Cliff, you're good?
Good, thank you.
All right, this is Radio Joe Hughes saying thanks to this week's guest, Danny Gough and Dr. Joe Spurgeon. We're going to have, 4 or 5 people next week, 2 or 3 from the IICRC and 2 from the RIA, talking about conflict of interest and the policies that they're putting together. I think this is kind of something that I know a lot of people look at it as like, it's an important topic.
Very important.
And we're going to talk a lot about it next week. So I want to thank my co-host, the Z-Man, Cliff Zlotnick, Grayson Gone Fishing Fisher at the controls. Most importantly, our audience and our sponsors. Will be back next Friday at noon with the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.